In Chapter 11, we are going to continue hypothesis testing, but Chapter 11 is all about two samples. So in the same way that we created confidence intervals with two samples, we are going to also create hypothesis test for two samples. In this video, we'll focus on one-tailed test for two sample means where sigma is known. Again, here is your summary sheet. We're going to check the same conditions that we did for one mean. So the exact same conditions, but now for both distributions. We're going to state the null and alternative hypotheses. Remember, when sigma is known, we're using the normal model, which means norm dist and z-scores and all of that. The main thing is now the test statistic is a little bit more complicated, but we're still finding the critical value and the p-value, and we're still rejecting or failing to reject for the same reason. So let's talk a little bit about the test statistic before we move on. The z-score is found by quite a bit. What we're looking at here is we're saying x bar 1, so that is the first sample mean minus the second sample mean. That's the first part. Okay, now what's this? Well, we're not going to be given two means. What this is going to represent is the hypothesized difference. Now, quite often, the hypothesized difference is 0. So I'm just going to put often 0. So if we're doing a test and we're just trying to see if there is a difference between the two sample means, our null hypothesis is going to be that those two means are equal to one another. If we want to see if there is a large enough difference between the two, we might think that we expect a 20 unit difference between the two. Well, then that would be 20 because we would expect a difference of 20. So again, the part that I've circled in green has everything to do with the alternative hypothesis, and that will begin to make sense as we look at more examples. Let's look at our first question together, and there's a lot going on here, so I'm going to do my best to break it down as easy as possible. So we're going to read the first paragraph, and from that we're going to be able to determine the hypotheses, and then we'll go ahead and find all of the values that we need. A university researcher is interested in a new instructional method for English for university freshmen whose scores require them to complete remedial work. He is comparing the traditional two-semester instruction. We're going to call the traditional two-semester instruction our first sample against the new one-semester co-requisite instruction. He wants to test the claim, so here's where we hone in. It's going to tell us what are we testing. He wants to test the claim that students who are in the traditional English remediation, which was, remember, that was 1, score lower than those in the new co-requisite course. So before we look at anything in the second paragraph, let's figure out what we already know, because we already know quite a bit. What we know is that the null hypothesis is that we should assume that they're going to score exactly the same. So unless it tells us that we're expecting there to be a difference already, then we expect for those differences in instruction to not make a difference in terms of their scores. So you can either write mean 1 is equal to mean 2, so mu1 equals mu2 for the null, and the alternative is based on score lower, so 1 scores lower than 2. Another way that you might see this written, and it's totally fine whichever way you choose to do it, is m1 minus m2 is equal to 0, and m1 minus m2 is less than 0. And so it's completely up to you which way you do it. I find most students think this way makes more sense, but really it's the same thing, because obviously using algebra, I could subtract m2 from each side and end up with this equation, and I could subtract m2 from each side and end up with this equation. So, or sorry, inequality. So you get the idea. It doesn't matter to me which way you write it. You might see it written either way. They mean the same thing. So that's what we know so far. Now let's take a look at what we need to know moving forward. 93 randomly selected students were chosen for the study. Of this group, 41 students were randomly chosen from the group who took the traditional remediation English classes. Now, which one was that? That was 1. So 41 is N1. There are 41 students in the first sample, those who took traditional 2-semester instruction. That group scored a mean of 66.47, so that's X bar 1. On the departmental final exam, the other 52 students, so again, now 52 students, that's N2. Notice I didn't write down 93 because I don't care how many students there are total. I care about how many are in each group. So 52 students were randomly chosen from the new, that's the second group, the new 1-semester co-requisite English class, and scored a mean of 69.43. So that's X bar 2. Assume that the population standard deviation for students in the traditional English class, which was 1, is known to be 8.05. So that's sigma 1. And for the other, it is 9.22, sigma 2. And then we are using alpha of 0.1. So at the top, obviously, I've copied again the summary that we just went through together. And now let's check the conditions. Obviously, it's more beneficial to check conditions as we are looking at the question, but this one's fairly straightforward. We're told that both samples were randomly selected. Obviously, I know both sigmas because I found them as I was reading the paragraphs, and both N1 and N2 are greater than or equal to 30. So very easy to check the conditions. Then state the null and alternative hypotheses. We have done that already. One thing I want to point out, again, we already talked about the fact that it's okay for this to be mean 1 minus mean 2 equals 0, and mean 1 minus mean 2 is less than 0. What we did not talk about is if we're saying that they're equal to 0 or less than 0, this is the hypothesized difference. So as I'm finding my z-score on the next slide, you will notice that when it says mu1 minus mu2, that I'm going to be replacing that with 0. Now, it doesn't matter which way I write it. It still means that if those two means are equal to each other, then their difference would be 0. So let's take a look. The test statistic, again, is first to take the two x bars and subtract them. And typically, we'll just do that in the order in which they give it to us. So x1, x bar 1 and x bar 2, 66.47 and 69.43. And then again, as I said before, I'm sorry, I was going to use a different color there. Mean 1 minus mean 2, this is the hypothesized difference. And we are assuming that the difference will be 0. And then because sigma is known, we're going to take sigma 1 and square it, which turns it into a variance, and sigma 2 and square it, which again turns it into a variance. We're dividing each by their respective sample sizes, adding them together, and then taking the square root to turn them back into standard deviations, and that will give us our z-score. Z-score is negative 1.651. Now, the same critical value, the same p-value, so this part should be easy because we've done so much of this already. The critical value is found using alpha, and again, it's a left-tailed test, so I can just do norm S inverse of 0.1, and that should be a negative value because again, if I'm looking at my curve, negative 1.282 and anything less than is a rejection region. And then negative 1.651 is down here in the rejection region, which means we're going to reject. Again, we should also find our p-value, and our p-value is just finding the probability that z is less than negative 1.651, which of course is my z or test statistic, and this was just using norm s dist. And again, p is less than alpha, which again tells us to reject. So now we will draw our conclusion. With p less than alpha, we reject the null hypothesis. And remember, when we reject, we're saying there's evidence to support the alternative. So there is sufficient evidence at the 0.1 level of significance to say that the mean final exam score for students who took the 2-semester remediation English class, which is just me telling you what M1 is less than the mean score for students who took the single semester co-requisite English class. Again, to create a corresponding confidence interval, I'm just going to use the formula. So just a reminder of the formula in case you don't have that little formula sheet that I made for you in front of you. X bar 1 minus X bar 2 is our point estimate. And then we have plus or minus. This is a critical value, and we're going to use the critical value for the rejection region the same way that we have in the last chapter. And then this is the square root of sigma 1 squared over n plus sigma 2 squared over n. And then we find our interval. And our interval does not contain 0, because if I had a number line, negative 5.3 would be here, and negative 0.7 would be here, and 0 would be over here. So that does not contain 0. In fact, it is below 0. So remember, your conclusion should include the 90% interval and what it means. So we're 90% confident that the mean final exam score for students who took the 2-semester remediation English class is between 0.66 and 5.26 points less, that's where the negative comes in, than the mean score of students in the single semester co-requisite English class. That's what the interval means. Then we talk about whether or not the hypothesized value falls in the interval. Now the hypothesized value in this case is 0. And so we say, since the hypothesized value of 0 does not fall in our interval, this supports rejecting the null hypothesis. Let's take a look now at how we can set up Excel to do these questions for us. So again, I'm just going to use a system where I have certain input values and then everything else will be calculated for me. And my inputs are the mean, the standard deviation, and N1, and then mean 2, standard deviation 2, N2, the hypothesized difference, and alpha. And everything else will be calculated. Again, for z-score, I'm just using the z-score formula that says take the first mean minus the second mean minus the hypothesized difference. Notice the parentheses. I need parentheses around the numerator. For the denominator, I need the square root of the first standard deviation squared divided by its sample size and the second standard deviation squared divided by its sample size. So that's going to give me my z-score, and if you'll notice, that z-score does match what we found when we did it by hand. Again, we're going to look at left-tailed and right-tailed in this video because they're set up the same way. So for the critical value for left-tailed, I'm just using alpha. So norm S inverse of alpha, the same way I have previously. And for right-tailed, norm S inverse of 1 minus alpha. For the p-value, for left-tailed, it's just norm S dist or norm dist. Sometimes I forget that I can use norm S dist. And either one works just fine. It's just a little bit less typing. So same value, norm S dist, and then of course 1 minus norm S dist for the right-tailed. You again can use the if p is less than alpha reject, otherwise fail to reject. So notice I've done that for all of them. And then comes the confidence interval. So this is new for this one just because the point estimate before was always the sample mean, but since we have two sample means, the point estimate is the first sample mean minus the second sample mean. So that's going to be my point estimate for my interval. That's going to be the center, whether it's one-tailed or two-tailed, that's the center of the interval. The E, or margin of error, is going to be the right-tailed critical value, and the reason we use right-tailed is because it's positive, and then times, again, it's the square root of the first standard deviation squared divided by the sample size plus the second standard deviation squared divided by the sample size. So you can see my formula right up there. To find the interval, I take my point estimate, which is E6, I'm subtracting E7, and I'm adding E7. And if you'll notice, all of these values are exactly the same as what we had found previously. Again, this video is going to be just a little bit longer because I'm going to do both left-tailed and right-tailed example in the same video. For this one, if you would like to skip straight to Excel once we get through this slide and we find all of the values that we need, feel free to do so. So let's find out what we need to know. A drug manufacturer claims that its new cholesterol drug, when used together with a healthy diet and exercise plan, lowers a patient's total cholesterol level by over 20 points. So let's just stop for a minute because this one is the tricky one. Our null hypothesis is that mean 1 minus mean 2 is equal to 20. Now, where did I come up with this? Because they are suggesting it's going to be by over 20, which means my alternative hypothesis is that mean 1 minus mean 2 is going to be greater than 20. So what we're saying is we expect 20, we want it to be over 20. And again, that's compared to someone who simply changes their diet without the drug. So we're going to use the people who use the drug as 1 and the people who simply change their diet as 2. And again, let's make sure that makes sense. Mean 1 is healthy diet and exercise. Mean 2 is just exercise. We expect that difference to be 20. And again, M1 we're considering to be the greater of the two, and that's why it's a positive 20. So hopefully that makes sense. Now let's continue and find all of the values that we'll need for Excel. To test the claim, a sample of 55 patients with high cholesterol is chosen at random from a cardiologist's list of patients to take the drug in addition to changing their diet and exercise plans. So there are 55 in N1. So the first sample has 55. Over the course of 3 months, this group lowers its total cholesterol by a mean of 44.7 points. The population standard deviation for this group is known to be 6.8 points. So that's everything for 1. Now let's look at 2. 55 patients, which is N2, with high cholesterol lowered their level by a mean of 23.1 points. So that's X bar 2. The population standard deviation for this group is known to be 5.3 points, which is sigma 2. And then, of course, we have alpha equals 0.01. Now, we'll go ahead and check conditions together. And then if you would like to skip over all of the handwritten work, feel free to skip forward until you see me working in Excel again. But for this one, again, we're going to check conditions. We are told both samples are randomly selected. We are given sigma 1 and sigma 2. And both N1 and N2 are greater than or equal to 30. So again, we've already stated our hypotheses. Mean 1, mean 2 is equal to 20. Mean 1 minus mean 2 is greater than 20. And then our test statistic, the only thing different here, the part that you need to watch out for, is this part's the same because we're taking the first sample mean minus the second sample mean. But this part is different because previously that was 0 because we didn't expect there to be a difference. And now we're saying we're expecting up to 20 to be a difference. And if it's more than 20, then we're satisfied. So 20 is what we expect to see. Everything else is exactly the same. So again, I find a z-score. I find my critical value. This time I used 1 minus alpha because it was right-tailed. And then p-value, again, is 1 minus norm s dist. and that gave me a p-value of 0.0844. Obviously, using either the critical value for the rejection region, which we can see that 1.36 would be inside if this was 2.326. This value is not in the rejection region, 1.376, and also we can see that P is in fact greater than alpha. Both say fail to reject. So again, based on both the critical value and the p-value, we can say with p greater than alpha, we fail to reject the null hypothesis. At the 0.01 level of significance, we have insufficient evidence to support, and remember, we're always talking about the alternative. So we're saying we don't have enough evidence to support the drug manufacturer's claim that the new drug, when used together with a healthy diet and exercise plan, lowers cholesterol by more than 20 points compared with changing diet and exercise alone. To create the confidence interval, again, all I'm going to do is take x bar 1 minus x bar 2 for my point estimate, and I really want to point this out to you because this is where a lot of students get confused. Notice that I'm taking my point estimate as x bar 1 minus x bar 2. What I'm not doing is subtracting 20. So even though when I was finding my z-score, I did have to subtract 20, when I'm creating my interval, I do not. And the reason I do not is because 20 is the value that I'm going to look for in my interval. So is 20 between the two values? Yes, it is. So at the 0.1 level of significance, we believe the true difference in post-test cholesterol levels to be 18.9 points and 24.3 points. So somewhere between those values. Since the hypothesized value of 20 falls in the interval, this supports failing to reject the null hypothesis. Again, I strongly encourage you to use Excel because we already went through just a moment ago how to set the spreadsheet up for one-tailed. This is a right-tailed test, so as I can see, it has found the correct z-score, keeping in mind that I need to include a hypothesized difference of 20, otherwise this will all be incorrect. I have the correct z-score, I have the right-tailed critical value, I have the p-value, I have failed to reject, and I have the interval. Up next, we're going to take a look at a two-tailed example.